The 58 Panther tanks that rolled toward Arracourt in September 1944 represented everything the German war machine could still produce. Brand new, fresh from the factory, armed with 75 mean high-velocity guns that could penetrate Sherman armor at 2,000 meters. Protected by frontal armor so thick that American tankers had learned to simply retreat rather than fight. These weren't tired machines scraped from other fronts. These were the pride of German engineering, assigned to General Hasso von Manteuffel's 5th Panzer Army for a single purpose: smash through Patton's overstretched Third Army and prove that German armor still ruled the battlefield. 1 week later, only 8 Panthers remained operational. The Americans hadn't destroyed most of them. The Germans had destroyed themselves. This is the story of how the most advanced tank of World War II became a catastrophic failure. Not through enemy fire, but through the fundamental flaws in the system that created it. The Panther was designed to be invincible. When German engineers first encountered the Soviet T-34 in 1941, they experienced what historians call tank shock. The T-34 combined sloped armor, wide tracks, and a powerful gun in ways that made German tanks look obsolete overnight. The response was the Panther. It borrowed the T-34's sloped armor concept and improved on it. The frontal glacis was 80 thick, angled at 55 degrees, giving it an effective thickness of nearly 140 minus. The 75 EVM KWK-42 gun was one of the most accurate and powerful tank weapons of the war, capable of penetrating 120 mm of armor at a kilometer. On paper, the Panther was superior to every Allied tank on the Western Front. The Sherman 75 EVM gun couldn't penetrate the Panther's front armor at any combat range. The Panther could kill Shermans at distances where the Sherman couldn't even threaten it. The mathematics seemed simple. 1 Panther should equal multiple Shermans. German planners calculated that their technological superiority would compensate for American numerical advantages. The mathematics were wrong. The first problem was invisible to anyone looking at specifications. The Panther was mechanically unreliable in ways that bordered on catastrophic. The tank weighed 45 tons, but used a transmission and final drive designed for a 30-ton vehicle. German engineers knew this was a compromise. They made it anyway because the war couldn't wait for proper engineering. The result was a final drive that failed with disturbing regularity. Panther crews learned to listen for the grinding sound that meant their transmission was about to seize. They learned to nurse the vehicle through turns, knowing that sudden directional changes put killing stress on components that were already at their limits. A Sherman could drive 150 miles before requiring major maintenance. A Panther was doing well if it managed 60 miles without breakdown. The German factories were producing mechanical marvels that couldn't stay running long enough to reach the battlefield. The second problem was the crews. By September 1944, the experienced German tankers, who had conquered France and pushed deep into Russia, were largely dead. The replacement crews receiving the new Panthers at Arracourt had received abbreviated training. Some had never fired the main gun in a live exercise. Many had driven fewer than 50 kilometers before being assigned to combat units. They knew how to start the engine and point the gun. They didn't know how to maintain a finicky mechanical system that required constant attention. They didn't know the sounds that warned of impending failure. They didn't have the experience to recognize when their vehicle needed rest versus when it could be pushed. The third problem was fuel. Allied bombers had been systematically destroying German synthetic fuel plants for months. The Panther's Maybach engine consumed fuel at a rate that horrified logisticians. Full combat operations required approximately 500 liters per 100 kilometers. The tanks that arrived at Arracourt came with barely enough fuel to reach the battle. Reserves were minimal. Manteufel knew all of this. He protested that his Panthers weren't ready for offensive operations. He was overruled. Hitler demanded an attack, and Hitler's demands were not negotiable. The Panthers rolled toward Arracourt on September 18, 1944. The weather that morning was fog, dense clinging fog that reduced visibility to a few hundred meters. The conditions negated the Panthers' primary advantage, its ability to kill at long range where enemy tanks couldn't fight back. The German commanders should have delayed until the fog lifted. They pushed forward anyway because their orders said attack. The first Panthers to break down did so before reaching the American lines. Final drives failed on vehicles that had barely traveled 20 kilometers from their assembly areas. Crews abandoned their machines by the roadside and climbed onto other tanks as passengers, hoping to find replacement vehicles. The Panthers that reached combat found something unexpected. The American tankers at Arracourt had developed tactics specifically designed to neutralize Panther advantages. They didn't try to fight at long range where the Panther's gun was decisive. They used the fog and terrain to close the distance, engaging at ranges where Sherman guns could actually penetrate German armor. Captain Tom Leach commanded a Sherman company that encountered Panthers near Arracourt. Instead of the expected long-range duel, his tankers fought at distances under 500 meters. Sometimes under 200 meters, where the Sherman's 75 mm gun could penetrate the Panther's thinner side armor. The fog that should have protected the advancing Germans actually helped the Americans. The Panthers couldn't use their superior range. They couldn't see targets until those targets were already close enough to hurt them. The combat revealed another fatal flaw. The Panther's turret traverse was slow compared to the Sherman's. In close quarters fighting, where speed of engagement mattered more than penetration at range, the Sherman could acquire and fire on targets faster than the Panther could respond. Tank after tank fell to shots they never saw coming. But the combat losses were only part of the story. The more devastating losses were happening behind the German lines. Panthers that survived contact with American tanks returned to their assembly areas with mechanical damage that field workshops couldn't repair. Final drives that had been stressed beyond their limits failed completely. Transmissions that had been running hot seized solid when the engines were shut down. The German maintenance system collapsed under the strain. There weren't enough spare parts. There weren't enough trained mechanics. There weren't enough recovery vehicles to tow damaged Panthers back to repair facilities. When a Panther broke down in the field, the crew faced a terrible choice. They could wait for recovery that might never come, sitting exposed as American aircraft hunted for targets. Or they could destroy their own tank to prevent capture and walk back to German lines. Dozens of Panthers were destroyed by their own crews. The scenes repeated across the battlefield. A Panther would grind to a halt with transmission failure. The crew would attempt field repairs that couldn't fix the underlying problem. Hours would pass. American artillery would begin registering on the immobile vehicle. Finally, the crew would place charges, destroy the tank, and retreat on foot. The Americans didn't have to kill these machines. The Germans killed them for them. By September 25, 1 week after the offensive began, Manteuffel's force had lost 50 Panthers. Combat with American tanks accounted for only a portion of that number. Mechanical breakdown and subsequent self-destruction accounted for the majority. The statistics were damning. Of the 50 Panthers lost, American tank fire destroyed approximately 20. American aircraft destroyed several more. The remaining losses, nearly half the total, were mechanical failures that resulted in abandonment or destruction by German crews. The invincible Panthers had been defeated primarily by their own engineering. The American commander at Arracourt was General John Wood, whose Combat Command A of the 4th Armored Division bore the brunt of the German attack. His after-action reports noted something significant. His Sherman crews weren't winning through individual superiority. They were winning because their tanks kept running while German tanks kept breaking. A Sherman that survived a battle could fight again the next day. A Panther that survived a battle might still be dead from mechanical failure before the next engagement. The reliability advantage compounded over time. Each day of the battle, the American tank strength remained relatively stable, while German strength diminished. Panthers that needed maintenance couldn't get it. Panthers that needed fuel couldn't find it. Panthers that needed experienced crews to nurse them through mechanical difficulties had green crews who didn't know what they were doing. The battle became a war of attrition that the Germans couldn't win, not because the Americans had better tanks, but because the Americans had tanks that worked. The Arracourt disaster forced German commanders to confront uncomfortable truths about their armored forces. The Panther looked impressive on specification sheets. In actual combat conditions, it was a liability. A tank that couldn't be kept running was worse than a tank that was slightly inferior but reliable. A tank that consumed fuel at impossible rates was useless when fuel supplies were constrained. A tank that required expert maintenance was dangerous when expert mechanics were dead or captured. The German obsession with technical superiority had blinded them to operational reality. They had built the best tank they could design. They had failed to build a tank that could actually fight. The lessons of Arracourt extended beyond the immediate battle. The same pattern repeated across the Western Front whenever Germans committed Panther units to sustained combat. Initial successes gave way to mechanical attrition that no amount of tactical skill could overcome. The Panthers' final drive became a running joke among American intelligence officers. They knew that German armored attacks would lose effectiveness within days, simply because the Panthers would stop running. They didn't need to destroy the tanks. They just needed to survive long enough for German mechanical failures to do the work. The irony was profound. The Germans had built a tank specifically to overcome numerical inferiority through technological superiority. The technology was so unreliable that it created exactly the attrition problem it was supposed to solve. 50 Panthers lost in a week. Only 8 still running. Not because American tanks were better in one-on-one combat. They weren't. Because the system that produced and supported the Panther was fundamentally broken. The factories could build beautiful machines. They couldn't build machines that worked. The training programs could produce crews that knew theory. They couldn't produce crews that knew practice. The logistics system could deliver tanks to the front. It couldn't deliver the fuel and parts to keep them fighting. Superior technology had been defeated by superior reliability. The Panther that could kill any tank it faced couldn't kill anything if it couldn't reach the battlefield. General Manteuffel understood this bitter lesson. He had warned that his forces weren't ready. He had been overruled. The 50 Panthers that became scrap metal on the roads to Arracourt proved he was right. The American tankers who fought at Arracourt rarely knew how lucky they were. They saw Panthers break down. They saw Panthers abandoned. They assumed the Germans were retreating due to American pressure. They didn't realize that many of those Panthers had been killed by their own engineering. The secret wasn't revealed until after the war when German maintenance records were captured and analyzed. The numbers showed that mechanical failure, not combat, was the primary killer of Panthers throughout 1944 and 1945. The most advanced tank of World War II had destroyed an entire brigade not through enemy action, but through its own flaws. The fatal weakness wasn't in the armor or the gun. It was in the final drive, the transmission, the fuel consumption, and the system that produced crews who couldn't keep the machines running. Sometimes the most dangerous enemy isn't the one shooting at you. Sometimes it's the machine you're sitting in. The Panther represented German engineering at its most ambitious. It also represented German engineering at its most self-defeating. They built a weapon that could win any individual fight and lose any sustained campaign. Arracourt proved that war isn't won by the best technology. It's won by technology that works. The Sherman wasn't superior. It was reliable. In a war of attrition, reliability was the only superiority that mattered. 50 Panthers became monuments to a simple truth. A tank that can't reach the battlefield can't win the battle. And 50 German crews learned that the most dangerous thing about their invincible machine was that it killed itself before the enemy had the chance. If this story of catastrophic system failure hit you the way it hit me, smash that like button right now. Every like tells the algorithm that the hidden truths of tank warfare deserve to be understood. If you're not subscribed, now is the time because we're uncovering another legendary weapon that failed for reasons nobody expected. Drop a comment and answer honestly. If you were a tanker, would you rather have the superior tank that breaks down or the inferior tank that keeps running? I want to know. I'll see you in the next one.